In this sublesson, we'll see how to use Python with NXOS software. Python is an easy-to-learn and a very powerful language which allows easy integration with other programming languages. Python is an interpreted language and is platform independent. Currently, there are two versions of Python that are supported, Python 2 and Python 3. The latest version of Python 2 is 2.7.16. For Python 3, we have 3.6.9 and 3.7.4. The Cisco Nexus switches support Python version 2.7, both in interactive and non-interactive modes. The Python support on Nexus switches provide programmatic access to the device CLI used to perform tasks such as POAP, EEM script, or verify configuration and performing backups. It can also be used for automating tasks such as data collection for troubleshooting. The Cisco package for Python is called Cisco. The modules of Cisco package can be accessed via the cisco.module name. We'll now take a look at how to access the Cisco package in Python on NXOS switch. We are now on a Nexus 9000 switch. In order to get into or access the Python interpreter, we can just type the command Python. And this will get us into the Python interpreter shell. Notice that the Nexus OS switch is currently running Python version 2.7.11. In order to deal with the Cisco package, you can run the command import Cisco. Once you have imported the Cisco package, you can look at the contents of the Cisco package using the help command. The help function and calling the Cisco package will return all the package elements or the package contents that are available for the Cisco package. So we have different package sub-packages such as ACL, BGP, Cisco secret, feature, history, interfaces, IP address, line parser, MAC address table, NXOS CLI or NXCLI, route maps, OSPF. All the various features that are available of this package can be used to perform automation tasks on Nexus OS switch. Another package that is worth looking for is the CLI package. The CLI package allows you to execute CLI commands on the Nexus switch. So we can have from CLI import star, and if you want to run the command show version, we can use the CLI command and say show version. And this command will return the show version output from this active NXOS switch. The CLI library has different functions. One is the CLI, which returns the raw output. The second is the CLID, which returns the output in a JSON format. If I want to collect the show version output in JSON format, I can use the command CLID and show version, and this will return the output in the JSON format with the different key value pairs out of which are segregated for the show version output. The key value pairs or the JSON output can be stored in a variable and then can be accessed using the key values that are part of the variable. Another command that is available is the clip command. The clip command prints the output of the CLI command directly to the standard output device. So I can run the command show version, and we got the actual output of how we run the show version command on the CLI of NXOS switch. Now we have seen both the Cisco module and the CLI module available with Cisco NXOS switch. We'll now see another example which will allow us to build a more interesting application on NXOS switch. So for that, we get into the guest shell, and from the guest shell, we have created a test.py file. So let's look at the contents of the test.py, and we can see that we are importing CLI module and importing the JSON module or JSON package, and we are trying to collect the output of show IP interface brief. And the show IP interface brief is being saved into the interface list variable, and we are initializing a variable named I. And if you are not sure what are the indexes or the keys which will be returned as part of the output of this command, you can actually run this print command and print out the interface list. So let me show you what I'm trying to do here. So if I edit the file vi test.py, and I can comment these configs, this code, and save it and say Python test.py, and if, okay, so yeah, test.py, it should be indented. So when I run this command, I get the output, and these are the key values that I'm receiving from this output. So we have the table interface, table underscore intf, and we have row underscore intf. So in the code here, what we are doing is we are returning the values of the table underscore intf, and from there we are getting the value of row underscore intf. And from each row, we are fetching the value of interface name and the link state. So we have the interface name, intf name, and the link state, which helps us know if the link is up or down. So if I go back and edit the code and say I uncode or uncomment these hash or these code lines, and I can comment print command or print function, and once I save it, I can say test python test.py, and it will return all the interfaces that are configured on the box and have an IP address which are part of the output of show IP interface brief. This is how we can use the Python scripts on NXOS Switch to automate certain tasks or fetch some values that will be used for automation purposes. We can also use the CLI module to add configuration onto the box. So say we just saw that we have loopback interface 0, 1, and 2 physical interfaces and VLAN 99. So I can use the CLI module to actually create a new loopback. So I can say CLI, say quotes, conf t. When you're requiring to get into the config mode and execute multiple commands, especially for the configuration purpose, you might want to put all the configuration into one single line rather than putting into different lines, because it will create a problem. So the CLI conf t, and we say interface loopback 100, and then we say IP address 100.100.100.100/32, and we close the quotes, and we should be good. So now if I execute the same Python script, now I should be seeing an extra loopback interface that is configured. So we have now loopback interface as well. And if I want to fetch the IP address along with the state of the interface, I can actually go back, look at the JSON output that we initially saw, and fetch the value of prefix. So the prefix is the value that will help us get the IP address configured on the loopback interface. So let's go back and edit, and here we can go down and say intf. We'll edit this, and we just add some extra space and say intf, and we will use prefix, and we are done here. So now when I execute the Python script, I should also be getting the IP addresses. We are getting some error because we couldn't find the intf prefix, most likely. We'll have to look into code. And I believe the problem is because rather than prefix, we have for Ethernet 1/49 and 1/50, we do not have prefix. We actually have IP disabled. So we do not have the prefix key under those interfaces, and that's why we are getting this error value. So you might want to use these values that you're using in the Python code based on the values that you're seeing in your initial output in the JSON format. And based on that, you can implement the code to fetch the values and print that out in your own way. And you cannot just do this, you can actually collect counters for different interfaces, and using a Python script, you can actually monitor the counters and perform certain tasks just based on if there is a software defect or even there is some network issue going on. You can use the script to actually prevent any kind of problem or perform a workaround for that problem using these scripts. So these can come in very handy.